All right, well, welcome back. This is Dr. Mears. I dropped my camera and I maybe try to bring the two videos together or post them as part one and then part two. So before I dropped my calculator, we were looking at this x-intercept and this x-intercept and what they represented, and this was of that skate ramp right here. And what I was going to do is I wanted to subtract 32.069 minus 7.97 to get that actual distance, which is 24.099. So subtracting x-intercepts will give you the total distance of the run. And remember, I said the ramp was the run. So total distance of the run is 24.099 meters. All right, there we go. Subtracting the x-intercepts gives you the total distance, since it's that horizontal distance. All right, last one, part two. What are you going to do? And this is the shot put one. So Omar is on the school shot put team. The path of the shot put is modeled by a quadratic equation. Y equals 1.5 plus 0.75x minus 0.05x squared, where y is the height of the shot put meters and x greater than 0 is the horizontal distance traveled in meters. We have to do a couple things. Part A is find the maximum height that the shot put reaches. B, write down the equation of the axis of symmetry. C, find the positive x values for when the graph crosses the x-axis and explain what this value represents. And then D, find the y-intercept and explain what this value represents. This is a really good problem. It really feels kind of like that summative type problem where you can bring it all together and make a story out of it. Weaving all of these content and concepts together. So first, this is not in standard form. If you wanted me to put it in standard form, I would just bring this negative 0.05x squared first, bring over the positive 0.75x, and then bring over my 1.5. So if you want that in nice, perfect standard form. Now what we're going to do is we're going to graph this on Desmos. And y is the height of the shot put, and x greater than 0 is the horizontal distance traveled. And now, if people don't know what shot put is, I found this picture. So shot put, there's either a ball or even a discus, and this person throws it in a very awesome way. If you're interested in shot put, you can always go to YouTube and watch a video. So it throws it, and here's the path of that shot put, and you can see it's very parabolic in nature. And there's some other things, but we don't need to talk about the angle at which it's released or anything. We're just looking for its path, and this is what it's modeled on. They use a lot, like sports analytics. This is what they use to see, how far can we get it a little bit further? At what angle will he have to or she have to throw it? But we're not doing that. We're finding maximum height. We want to know how high it goes. So we're going to graph this equation in Desmos. And here's what it looks like. And here's the thing. Yes, there is the red. That is showing you all of the curve where x is greater than 0. So we're disregarding this side over here. So there is a person right here holding the shot put and throwing that shot put. That's what they're throwing it from there. And then it's reaching its max height, and then it's hitting the ground. I don't even think we need that part. We actually just needed that part of the graph. That's what was mapped right here. So really understanding, I'm trying to have you put a picture with your graph. Now again, I labeled everything. Horizontal distance that the shot put traveled, height of the shot put, horizontal distance of the shot put, height of the shot put. So this is his start point right here. This is our y-axis. So remember, y-axis usually means some type of start. So this is he or she is holding it at 1.5 meters. Here's the vertex. So this is the vertex. And here is that last point where the height is at 0. So this is probably when it hits the ground. And this is the horizontal distance. So that's probably from 0 to 16.787 horizontal distance. We've been working with that. Okay, so let's first, part A, find the maximum height. So maximum height, here we have right here. Let's look. This is the horizontal distance. That's the max height. So let's put part A, maximum height of shot put, and I like to put of what, is 4.313 meters. And it's nice because I label it all right here, so you have it. Okay, what's next? What are we going to look for next? Part B. Write down the equation of axis of symmetry. Remember, that axis of symmetry is that imaginary line that goes right through the vertex that cuts the graph in half. So part B, it's the imaginary line. It's this line right here. It goes through the x-axis. So we have to look for that x number. And so we're going to write axis of symmetry is x equals 7.5. The reason why we're doing x and the equals, like physically writing down x and equals, is because this is the imaginary line. We need an equal sign, and it's whatever this number, this x number, is. That's your axis of symmetry. That's it. On to part C. Part C, find the positive value for x when the graph crosses the x and explain what this value represents. Let's go find it. Well, here's the negative value. We don't want that one. That one's out. We don't need that. Okay. Here's the positive value. Ooh, cool. Look, it's the horizontal distance the shot put traveled, 16.787. Remember, it started from 0. If it didn't start from 0, we would have had to subtract these, but it started from 0. Okay, let me say that one more time. Since it started from 0, we know it went from 0 to 16.787. If it didn't start from 0 here, then we would have had to subtract these like we did back in our skate park run example. All right, so it traveled 16.787, and that's when it hit the ground. So that's what it represents. So let's write that down. Part C. The shot put traveled 16.787 meters when it hit the ground. There we go. That's it. And last one, finally, y-intercept, and explain what it means. Finally. Okay, part D, y-intercept. So here we go. Here's our person. Here's our y-intercept. So here's the person, so the distance, so it hasn't gone anywhere. Here's the height, that's how the person is holding it at 1.5 meters. So the person is getting ready to throw. And is holding it. Holding the shot put at 1.5 meters above ground. There we go. And that's applications. So I'm hoping you're understanding what they're asking for in the problem and how it's really lining up with the picture. And if once you can put the picture over the graph, then I'm hoping some of this other, finding what it represents and writing it in context will just come a little bit easier. So that has been applications. Sorry for the 2-part series where I totally lost my calculator. This is Dr. Mears. Hope it helped.